So I'll go ahead and get started with the quote-unquote syllabus. It's not really a short syllabus like what we are used to in the past. So they're getting longer and longer and longer. I try to keep mine short, so only the necessary information. All right, first thing, these are class-specific information. So this class does have two prerequisites. One is CISP 360, and it also has a prerequisite of Math 370. So I'm not really too concerned about how much you know about certain concepts in pre-calculus. We are going to work with limits just a little bit. So understanding the concept of limits is going to be helpful. Okay. CISP 430 is a co-requisite, which means you can be taking CISP 430 in the same semester or prior to this class. Okay, so that is expected. So when I talk about trees and other data structures in this class, by the time I talk about trees or graphs, you should have taken, or those concepts should be covered in CISP 430 already. Okay, so I'm expecting you guys to know the co-requisite and prerequisite of this class. So the description is here. That's the usual stuff. You can easily find all that stuff. This is the student learning outcome, which normally you don't get to see, but this is a reference for you guys to kind of cross-check at the end of the semester to make sure that you kind of learn all of the concepts that you're supposed to learn in this class. And then this is just a list of topics and approximately how long it takes for each topic for me to go over. The ordering is actually off a little bit. I would talk about set theory first before we go to function, because the concept of functions depend on the concept of set. So, so the order is reversed on a few items here. But otherwise, for the most part, that's the correct order. So are there any questions about this part here? No questions? It's all good? Okay. So if this is okay, we're going to go, yeah, go ahead. There is no textbook for this class. Yeah, there's no textbook. I write all the material for this class. Well, wait until you see what I write, right? That may be a little too soon. All right, so the syllabus is kind of common to all my classes. If you have taken at least one class from me before, you have seen this stuff already. So I usually don't change this part too much, except for the office hour and stuff like that. So my name is Tak. Okay, last name is really hard to pronounce, so just go ahead and call me Tak. If you want to add a title, before Tak, you can call me Professor Tak. You can call me Dr. Tak. You can call me Darth Tak. Okay. See my T-shirt? No, it is not baseball. Baseball. What is baseball? This is the phone number. The best way to talk to me about class stuff is email. Okay, email works much better than phone. So here's the email address. My office hours for this semester on Mondays and Wednesdays is 8 to 9, kind of early in the morning. If you need to talk to me after class, that's okay too. I usually do not have anything scheduled after this class other than, just biking home. On Tuesdays and Thursdays, it is from 4:30 to 5:30. And then on Fridays, it's going to be from 10 to 11 o'clock. So do we have any questions about, how to contact me, where I'll be at, during my office hours? No questions? All right. This is a full face-to-face class. There's no hybrid components to this class. So, mostly it's just reading material, lecture, and you have, homework assignments and the usual stuff, okay? Nothing too uncommon about this class in terms of how it is delivered. Regular effective contact and communication policy. The most important part is really, how to contact me. We talked about the office hours. We talked about the email and the phone. You can also use Canvas to talk to me or to, kind of text me, using Canvas. I think that is the preferred way of contacting me because it leaves behind a trail in Canvas. So when we get accredited, the accreditation team can look at the statistics and go like, oh yeah, I can see people contacting you and so on and so forth. The time frame policy basically says, I can get back to you in about 24 hours from Monday to Friday, and then weekends is about 48 hours. Okay, so that's kind of the turnaround time of, when you ask me something online, how long it takes for me to get back to you. Behavior policy, just kind of common sense, but I do need to go over. 7.1 is basically just, distracting behavior in class. It's kind of interesting, these classrooms, because they are temporary buildings, the floor is not very solid. So I have had people who kind of fidget, like, just shaking their legs, and they can be about, I would say about 8 feet away from me, and I could feel it. And I would suspect, people within like a radius of 8 feet would also feel that. So that was distracting to me. I was teaching the class. It has to be distracting to people around that student as well. So it's not a problem in many other classrooms, like Rave Hall, not a problem. But in these, classrooms, that tend to be an issue. Cell phone ringing, that can be distracting. So just kind of turn off the ringer during the class. I use Do Not Disturb on mine, and I tie in the class schedule with Do Not Disturb. So the phone automatically knows that I'm in class, and it turns off the ringer automatically. So that's a pretty useful feature. The second one is kind of more disturbing behaviors that are basically intended to cause fear, the feeling of intimidated or discomfort. So those are definitely, not tolerated at all. Okay, not in a classroom. Okay, is that okay? All right. First day of class, not an issue because you're already here. That reminds me to pass the row sheet. So I'm going to start with this side. Make sure you have a chance to just initial next to your name, okay? If you're on wait list, your name should be on the wait list too. If you are beyond the wait list, just add your name, after the wait list. But do not take the permission number, okay? So I'm going to deal with permission numbers later. If your name is not even on the wait list, make sure that you write down your student ID next to your name, because this is how I know, who needs a permission number when I get back home today. Okay? All right, there you go. Section 9 about accommodations. If you need any accommodations, check with the DSPS office. There's a phone number here, for the DSPS office. I cannot really do any accommodations in class unless I get a letter from the DSPS office. Okay? You guys doing okay? All right. Excessive absence, basically, without any excuse at all, without any particular reason, you can miss up to 2 lectures. The third one is going to be excessive. Okay, if you're sick, it is excused. So this only applies to absences where you do not have an excuse. Okay, or whatever reason you have is not one on the list of things that can be excused. So that covers that one. So let's see. So that's that. These particular items are not excused. In other words, the college and the district does not have a policy to accept any one of these reasons as an excuse for absences. Okay, so you can use one of those too, okay, for these reasons. Late policy, basically there's no late work. Any late work is not going to be, will not receive a grade that counts to your letter grade at the end of the semester. Sometimes I get people requesting me to say that, I know this is not going to count, but I still want it to be graded so I know whether I got it right or not. So I can grade it for that purpose, but the score is not going to count to the grade if it is submitted late. I can almost say for sure, in this class, all the homework assignment is due in at least 1 week, typically 1 week. So just kind of pace yourself and time yourself accordingly so that you won't be late. Okay. The next section talks about academic honesty, integrity, or dishonesty, depending on how you look at it. So I'm just going to talk about looking at this from the perspective of integrity. So this is the key to how I look at this. The grade of a particular assessment, like a homework assignment or an exam of a particular student, reflects the academic performance only of the student with the name on that piece of paper, or turning it online, of a student of that account. Is that okay? All right. So in this class, I do not expect, and I don't think we will have group work or teamwork. So every homework assignment is supposed to be individual. You're supposed to do it yourself. And regarding exam and homework assignment, this is basically saying, if I have an exam on Wednesday and somebody, show up on Friday during my office hour and go like, can I take it now because I somehow, could not make it on Wednesday? Unless that reason is because of sickness. In this case, because it's an exam, I will need verification from a physician. So unless it's one of those reasons, I cannot give that person a makeup exam. Okay? The student has to follow all the rules of the assessment. So if the rule says, it is not open book, then books cannot be used. But I can tell you already, with all the exams of this class, they're going to be open book and open notes. Anything that is handwritten or printed prior to the test, you can bring. And there's no limit on quantity other than physical limitations. Okay, there's only so much space on your desk. Okay, you guys have tiny little desk space. Okay, so kind of allocate your resources accordingly. Okay, but other than that, you can have 2 pages of condensed note. You can bring all 60 pages of your notes. You can print out all the modules that I have written and bring it with you. Okay, it doesn't matter as long as it fits physically on the desk in front of you. Is that okay? All right. But no electronic resources. So you cannot use your phone during the test, to look at the PDF. So if you think a PDF is going to be helpful, print it out and bring the paper copy with you. And that kind of brings us to the 4th point here: only using resources allowed during the assessment. Because it's open book and open notes, and you can bring a scientific calculator, that's typical of this class. If you think of something that you think you might need, but it may not be on the list that is allowed, check with me first. Okay? Is that okay? All right. Let's see. I'm gonna skip the limits test here. Basically, how I, in case of doubt, okay, if I suspect, student A was copying an answer from student B, how would I go about, proving it one way or another? 13.3 is about the importance of talking about academic integrity. Why is it important? Because really, it is a whole lot easier for me to turn a blind eye and just go like, well, here's the test. I'm going to go out, and I'll be back an hour later. Okay, instead of staying here and actually doing the grading, checking for things. So the importance is, if we, as faculty, if we do not pay attention to that, we can end up with inflated grades. Okay, some people who may not be deserving an A is getting an A out of a class. So that doesn't sound too bad, right? Well, until it becomes a pattern. And when it becomes a pattern, the schools or the universities that we articulate with will start to say, well, we don't want to articulate with ARC anymore. So now your degree is worthless. Not only yours, but everybody's degree is going to be worthless. That would not be good. Okay? And there are cases where you might feel, wrongfully accused, not by me, not just me, but other professors as well. So this is a good document to read because it tells you what rights you have as a student here. Okay? You might want to read it before you need to use those, resources. Okay? Just to understand, okay, so how much can I take, from a professor? Okay? At which point can I file a grievance and say, either I'm not treated, fairly, or the professor is not doing what he's supposed to, and so on and so forth. So good document to read regardless. Section 15 is kind of a repetition of what we talked about already. Basically just typical classroom behavior. If you have a question, it's better to ask me instead of the student next to you, because if you ask a student next to you, not only are you not then paying attention to what I'm saying, but the student who is listening to you to try to answer your question would also not be listening to me. So it's better just to raise your hand and tell me, and say, okay, I'm not quite getting that concept, or, I think you meant blah, 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 okay, because occasionally I use the wrong word or the wrong term, the wrong symbol, okay. It's better just to raise your hand and let me know instead of talking to another student. No phone, drink, and food in the classroom. These posters are new, okay, because of an incident last semester. Not from a student, but from one of us. The lab tech, found that a keyboard, I think it's either this room or the next room, was basically drowned in coffee. And it was an instructor workstation, so so now they put that sign over there, okay, which is probably okay. It's good. How to attend lectures. You guys are seasoned students, okay? Because you're taking this class, you cannot be your first class, right? But this class has recorded lectures. So everything that you see on the screen, as well as my voice, is recorded on YouTube. It is streamed to YouTube, every single class. So unless I forget to do it, or unless there's a technical difficulty, like my mic runs out of battery, or the system crashes or something like that, which doesn't happen often at all. Okay, so unless that happens, it is recorded, it is streamed. So it may not help you that much by copying everything down, because it's already recorded. Okay, instead, it might be a better use of your energy to focus on what I say, and then see if you can come up with questions. I like questions. Well, the ones that relate to the class. Because questions really help me to understand, whether you understand the concept or not, what you do not understand, because remember, it's not your fault if you're not understanding the concept. I did not explain it well. Okay? So if you have a question, you're not quite getting what I said, you can just let me know, okay? And trust me, if you have a question, 30-40% of the class probably has exactly the same question. And everyone is waiting for a hero or heroine. So you can volunteer to be that person. Is that making any sense? Okay. Is that kind of your experience too? Like, after you ask a question, after the class, people say, thank you for asking that question. I had a question I just didn't want to ask. Do you get that, when you ask a question? Sometimes? Sorry? Good.
I said most people just call me dumb.
There are no dumb questions. Now, there are questions that reflect, study skill that has room for improvement. But there are no dumb questions. How to succeed in this class is a pretty long section, number 17. I just want to kind of give you the emphasis of section 17. When I give you exams, it is not about memorization. So it doesn't make sense to me to try to memorize things. Okay, not in this class, not in a programming class, not in a computer science class. What I'll be testing you is whether you understand concepts or not. Okay, so there's no regurgitation. Okay, give me the definition of something. Nope, that's not going to happen. So there's no need to study in that quote unquote conventional sense to try to memorize stuff. But you do have to understand it. Okay, there will be a lot of symbols that we use in this class, mathematical symbols. You really need to understand those symbols. Okay, how they relate to each other, how they can stack up to form bigger and more abstract concepts and stuff like that. That you do. Okay, so if understanding the material is important, then the next question is, do you know that you may not be fully understanding a particular concept? That really is the biggest question. Some people can, and some people do not seem to kind of detect, that feeling of I'm not quite getting it. Okay, it's difficult for me to put this into words, but I do find that there are students who can instinctively know. Okay, just know and perceive and say that I'm not getting this concept, and they know how to ask the question. They know how to ask questions like, okay. Does this mean A or does this mean B? And they use this to try to differentiate and try to confirm whether their understanding is correct or not. Okay. So the biggest question now is, how do you know whether you understand the concept correctly or not? And I don't really have a good answer, for that. And if I find anything, I'll let you guys know. When I was a student, when I was on that side of the fence, I was pretty good at knowing whether I understand the concept or not. And if I do not, either I ask the professor, I read the book, or I just kind of think about that for days and sometimes even weeks until I really, really get the concept. But it's not something that is procedural. It's not like, okay, here are the points, A, B, C, and D. If you follow these steps, you'll succeed. So I can't really quite outline that, in this class. If I find any tips, I'll let you guys know. But that is a very important skill to have, okay? So these are all, just discussions of that. Okay, problem solving. The exam questions you will see in this class, they will test your understanding of the material by asking you to solve problems. Okay, so if I use automotive technology as an example, okay, so in class I might talk about the mechanism of a spark plug, the ignition coil, okay, fuel air mixture, the optimal fuel air mixture, timing, and stuff like that. I'll explain each one of those concepts. But in the exam, I'll give you a scenario. Okay, this engine has a problem. Okay, the intake has these parameters, the exhaust has these parameters, and so on and so forth. Okay, tell me, what potentially can cause that problem. But tech, you never said anything in class about how to analyze an engine based on the intake and based on the exhaust to figure out what component may be at fault. I may not have done that, but I told you everything that you need to analyze the problem. So the analysis is your part, okay? Is that making any sense? All right? But I will in class, demonstrate certain types of reasoning, and I will spell out the way that I reason. Doesn't have to be the same way that you reason, okay? But I will try to spell out reasoning as the best I can in this class. Is that okay? All right. So problem solving is an important thing, and 17.3 talks about independence. In other words, when do you ask for help? That's the question. Okay, so let's say you have a homework assignment. Okay, it's due in a week. It involves a bunch of concepts, a bunch of techniques and whatnot. Okay, so the question is, when do you realize that maybe it's a good time to ask someone because I'm not getting anywhere. 5 minutes after the assignment is assigned, you just finish reading it and go like, I'm just gonna ask Tim about this. That might be a little too soon, don't you think? Okay, 5 minutes before the due date, that might be cutting it a little close. So there's a kind of a range of time where it is probably a good time to ask. I would look at the timing and kind of work on it by yourself as much as possible before the next class meeting, because it's due in a week, so that means it's due in 2 class meetings, right? So I will work on it until the next class meeting. If I'm still stuck at that point, I will kind of either go to the office hour, ask me in person, or you can ask it in class. Okay, I'm more than happy to talk about homework assignments during lecture time. Does that make sense? Because that will give you one more lecture time, to complete the homework assignment after you ask about it. Is that okay? The problem of asking too early, what is the problem of asking somebody else too early into a homework assignment? Exactly. Yep. And you want to add to it? So what is the difference then between somebody telling you the answer as opposed to you figuring out the answer?
At least you can actually show your understanding to somebody else once you try your best to come up with your own solution. And then that somebody else will figure out right away, oh, okay, this is something you probably don't understand, like what you do.
So let's say that concept is needed in one of the exam questions. Which way is more likely to kind of which way is going to be more likely to be retained? The knowledge is going to be retained by the time you take the exam.
The time where you actually understand what it is you're doing, even if you did receive something. But it's ultimately going to happen. That retention is going to happen once you fully understand what you're doing.
And if you spend more time on it, and then you ask somebody, as opposed to less time and just let somebody give you the answer, if you try to solve it by yourself more, then it is more likely for that concept to be retained in your mind. You want to add to it?
When you ask somebody else for help too early, you become reliant on other people.
Well, it can be. It depends on the nature of asking. If you ask someone, and go like, I'm not fully understanding this concept, and then you ask, okay, one way to understand, one way is this way, this is one way to interpret it, and this is the other way to interpret, and you ask the other person, what do you think? It's not too bad. On the other hand, if you're asking for a solution, okay, so let's say the question is, okay, derive X, Y, and Z from A, B, and C, okay. So if you're asking for the solution itself, then it's not going to be very helpful, other than just getting score for that particular assignment. On the other hand, if you're just if you're asking, okay, I just need a little pointer, okay, how do I approach this question? That might be helpful. So there are different ways to ask for help, depending on how you ask for help and depending on how the other person answer the question. Those are all the variables. Okay. So moving on to stuff that you actually care. Grading standards. So the rubric that I use for grading homework assignments and also mostly questions in the exams is I just evaluate an answer in A, B, C, D, F. Okay? And you guys know the GPA stuff, right? You know A, B, C, D, F already. So I'm going to evaluate an answer and say, is it an excellent answer? Is it a good answer? Is it a satisfactory answer? Is it a low pass answer, or is it a failing answer? So all those are the questions that I will be asking when I grade the exams. But what does it mean to be excellent? What does it mean to be good? Okay, because those are just words, right? What is excellent? Excellent means flawless. Okay, that's exactly what I'm looking for. Okay, it's an A. Good means, well, it shows the answer reflects that the student understands the concept, but with some minor mistakes or omissions. Okay, so this is where I make a lot of mistakes that would put me into that category. Like if you ask me what is 23 plus 17, I might give you the wrong answer. Okay, my arithmetic is really kind of erroneous. Okay. But if you ask me, do you understand the concept of adding? Yeah, I do. But it's just that when I try to do the carry thing, sometimes I got it wrong. Okay. A C means the answer does show sufficient understanding of the concept, but with major mistakes or omissions. So the question of is it a minor or is it a major? No, it is not in the musical sense. Okay. It has to do with whether it is. It's kind of difficult to say to generalize for all questions. Okay. A D basically means the answer does not show sufficient understanding of the material, what I'm testing on. Okay. It does show some understanding, but it's not enough. And F means it does not show any understanding of the material at all. Okay, I ask you, okay, somebody asked me, so what is the cause of this problem, this engine stalling problem? Okay, and the answer is, well, somebody stuck a banana into the exhaust pipe. From a movie, right? Which movie did it come from? Yes. So that would be an answer that would deserve an F, although I might put a smiley face on the paper. All right. So the rest of this table is kind of give you some analogy of what is an A in terms of job evaluation and also product evaluation. Okay. So what kind of product on Amazon is going to get 5 stars? Okay, what kind of product will get 4 stars, 3 stars, 2 stars, and 1 star? Okay, so I'm just using these to help you understand, how I evaluate an answer. Is that making any sense? Okay, and that's about it. We have 20% of your grade in homework assignments. We have 20% of your grade in the first exam, which is the kind of 1/3 through the semester. Another 20% in the second exam, which is 2/3 through the semester, and then 40% in the final exam. Any questions? Oh, I didn't show you the the allocation of the points. So an A is anyone receiving 87.5% or more. A B is between 62.5% and 87.5%. A C is between 37.5% and 62.5%. A D is between 12.5% and 37.5%, and so on. The reason why this looks so different from your other classes is because I just take the center point of each grade. Okay, 100% is the center of an A. 75% is the center of a B, 50% is the center of a C, and so on. So the threshold to cross over to the next grade is the midpoint between two of those center points. And that's why I came up with all of these thresholds. It is possible because I don't do multiple choice questions. Okay, there are no multiple choice questions. There's no padding to the exam questions. Okay, so there's no need to fill it up to 60% to start a D. In other words, it doesn't make this class any easier than the other classes. Is that okay? I just want to give this warning ahead of time. All right. So are we good with the syllabus? I just went through the main points. I didn't go through all the details. Yep. Uh-huh.
Is there a schedule or advance warning to when the exam?
I will give you at least 1 week warning before the exam because I give you a practice test 1 week before the actual test. So you will get at least 1 week, but usually I will also give you at least 1 lecture or sometimes 2 lectures ahead of the practice lecture, practice test. So you get somewhere between a week and a half to 2 weeks ahead of time before the actual exam. Yep. Any questions? No questions? All right. If there are no questions, we're going to go back a little bit. So you will see all the material in this class. They're kind of in this format. There's some kind of quote-unquote random module number, a title, and then there's the PDF and also the HTML document. The PDF is, well, it's a PDF. It's good for printing. Okay, so if you want to print it out, put it into a binder, go ahead and download the PDF, print it out. On the other hand, if you want to review some of the material and you don't have a computer, even a tablet or a cell phone can view the content fairly efficiently because it's all just mostly text. There are some math symbols in some of the modules, but most cell phones can render the math symbols fairly well, so should not be a problem. All right, so the syllabus is done, and we're getting back to the modules. So all of my notes, have module blah, blah, blah in front of it. And that's way before Canvas, way before we started to use Canvas. So that module does not correspond to module in Canvas at all. Okay, it's just that I call, each paper or each writing, each article, each document a module. All right, so we got these 2 items covered. The next one, this one is just a video presentation. So I have a pre-recorded presentation of the syllabus, but since I just talked about it, there's no need to go over that one. This is the final exam schedule for all the classes, not just for this one. So let's see if you guys know how to find the final time for this class. It's a good test of your problem-solving skills, right? It's a Monday, Wednesday class, okay, so we can focus on just the MW or the MWF. The start time is 12, which is noon, so it's going to be this one, right? Yep. So it's going to be May 20th, the Monday, and then the exam starts at 12:45, and it will end at 2:45. So you might want to put it on your calendar right now, just so that you know that the final exam for cisp440 is going to be on that day. Is that okay? All right. All right, so we got that done. So I think we can start on the fun stuff now. So with certain classes, I like to talk about, MBTI, or personality tests. This one is actually kind of interesting. I personally, think it is kind of cool. You can find a lot of resources like that. And they have charts, based on what you like to watch. So if you like to watch My Little Pony, they will basically give you an idea of, the INTP within the ponies, okay? So you have an idea of, what is an INTP, right? Based on popular media. Or if you like Lord of the Rings, The Walking Dead, Harry Potter, Disney princesses. And it's a beautiful chart. Okay, we got to show this one, right? So there are 16 personalities. So if you magnify this, we have the idealist, the protector, I think that's Pocahontas, the giver, Huh? That may be the case. This is Belle, right? And you can see ENTP is not exactly a princess. I wonder who is INTP? Oh, INTP is Alice. That might actually make sense. Okay. She's not a princess though. And of course, all of these things have to be adjusted now that Disney has acquired Lucasfilm, right? Where's Leia in this chart? She's a princess. She's a princess with a blaster. All right, so now MBTI or personality types, why do we want to spend time to talk about it? I mean, you made it so far into computer science, so it's not like, I want to tell you, oh, you got the wrong personality type for computer science. No, that is not the intention at all, okay? Because even within computer science, even within occupations in computer-related fields, there are different branches. Like, I would make a very poor choice for UI, UX type of thing. UI, UX is user interface, user experience, because I can use just about any user interface. And I cannot even tell, oh, that's a really, really poor user interface. Oh, really? I can use it just fine. People were amazed that I was able to program VCRs without any manuals. Now, we are not even talking about the on-screen programming fancy stuff, of the later VCRs. We are talking about VCRs with no on-screen programming. Everything is done by those blinky blue lights on the VCR. And then the remote control, has no, fancy buttons either. So you kind of have to know the sequence of, which button to press, to move on to the next one and adjust and stuff like that. And I think that was fine. We don't need a better interface at all. You mean you have to hold these two buttons, and when you double click that button and then release only one of these first two buttons and then release the other one? Yeah, I can do that. So yes, I would make a very poor choice for user experience and user interface design, because I kind of lack that element of, okay, my way of approaching things is a little bit different, okay? So there might be certain types of people who kind of land with a personality that aligns more with user experience and user interface. How many people know what is a systems analyst? It's a pretty important job, okay? Because you have to figure out the requirements of a system. You have to talk to the potential users of the system, the owner of a company and stuff like that, to try to figure out the parameters of an information system. I would make a very poor choice for that also, because I don't like to talk to people. No, I don't like to talk to people in a way that would not offend them, or, because if I ask someone, okay, so what do you think is inefficient about this system? Okay, I would just kind of ask a question without really factoring in the feeling of the other person. So they might feel that, I'm criticizing something when that was not my intention. I just need to know something, okay? But there are people who are much more polite, okay? They can actually watch or understand the body language of somebody else, so they make people feel a lot easier, and then they can get more information out of other people. So they will make much better system analysts than I do. Technical support. I will make a very, very, very poor choice as a technical support person. It's not like that I'm impatient. Okay, I can be pretty patient and logical and stuff like that, but I'm not very empathic. Okay, the other person can be crying on the line and go like, if I don't get this program to work, I'm going to commit suicide. And then I'll just go like, sir, that would be illogical, because if you're dead, you cannot work on the problem any further. So let me walk you through this one more time. I got all day here. That may not be good as a technical support person, right? I will do well as a developer. I will do well as a troubleshooter. Because what is more fun for me than programming is debugging somebody else's program. This program doesn't work. Well, as long as I didn't write it, I'll help you find out what's wrong with it. Because I really like that process. It's like a game. It's like a mystery, right? You're solving a mystery. Okay, the program has all of these symptoms. It doesn't work. Here's the source code, and sometimes even the source code is not available. So how do you find out what the problem is, and how do you solve that problem? Okay, you have to use all kinds of tools available at your disposal, or if there are not enough tools to begin with, then you make your own tools. Okay, so I like that sort of work. Okay, so I will make a good troubleshooter, or as they say, firefighter in a company. Here's a fire, tackle over and fight it, right? I will also make an excellent wet blanket in a company. Okay, there are certain people with a lot of ideas, but not many of those ideas are actually sound and feasible. I'll keep those people in check. My boss used to be that person, and he will call me in his office and go like, "Tech, I got a great idea," and blah, 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 blah. And they'll go like, "But Norm, it has been done already." Oh, okay. Or it cannot be done. Or this is not a good idea because blah, 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 blah. Okay? So I was the wet blanket. So the fire doesn't start at all. So there's no fire to fight later on. Right? So the personality type thing, can kind of help you understand which role is really suitable for you in all the choices of computer science related careers. There are many, okay? I'm a good fit for certain ones, and I'm a bad fit for certain ones too, okay? So if you want to find out what is your personality type, you can go to 16personalities.com. This is one of them, okay? There are many other ones too. Nope. I misspelled it. 16personalities.com. There we go. Yep, this is the one. It's really kind of cool. It's kind of fun. Once you have taken the test, you might actually want everybody that you know also to take the test because, with some people it describes very accurately. If you take the test without overthinking the questions, it should be fairly accurate. Okay, it would put you into the personality type that describes you. If you are a person with kind of like you're not really extremely leaning in either direction of the 4 letters, you may not find something that describes you really well. Okay, but for most people, I think it's actually not bad as an assessment. Okay, take it with a grain of salt, of course. Okay, this is not like it's not approved by any society of psychology or anything like that. But for the most part, it does have certain merit, in these personality tests. Is that okay? All right. Since I'm here, I'm going to digress even more. This is really interesting. Do you guys know what is Watson? IBM Watson, the AI engine? Okay. But they can also do personality assessment, personality insight, which is kind of strange, right? This is an AI thing. It's not a test. So what is it? So you go to the website, get started. Oh, no, this is the wrong one. I don't want to buy IBM products. Go away. Okay, view demo. There we go. So this is somebody trained Watson, with samples, and they learned from those samples. So one thing you can do, you can look at, based on the tweets of famous people, you can kind of tell what kind of a person they are. This is based on Big Five or Ocean. Ocean is OCEAN. O stands for openness. C stands for conscientiousness. E stands for extrovertedness. A stands for, what was A? OCAN. I know what N is. N is neuroticism. Yep. Agreeableness. That's right. Okay. See, if I score low on something, I cannot remember what it is. So based on those things, this is analyzing Opera's public, Twitter, text. So if you click it, you can find out, the evaluation of the engine. Analyze. There we go. Forgot to click that. And this is actually done in real time too, so it's not like pre-stored text. So you can see, according to the analysis of the Twitter text of Opera, she has really, really high agreeableness, really high conscientiousness, pretty high openness, more extroverted than introverted, but not extreme. And emotional range is about 50%. I guess it's not like, these are all percentile, by the way. Okay, so 50% means 15 percentile, which means, half of the population have a lesser emotional range, and the other half has more emotional range compared to Opera. Okay, so it's kind of cool. So how do you get your results, right? I mean, I'm hoping you're kind of wondering about that. So you can use your Twitter personality. Okay, I don't have a Twitter account, so it's not going to work. But you can use body of text. And in body of text, you can use your own text here. So, the more words, the better. So you can plug in, all the paper, all the stuff that you have written for English writing 300 or 480, okay? And it'll do some analysis and it'll give you a result. It's kind of fun. I plugged in all my Quora, answers. And that gave me a particular, personality. Now it's not complete because, when you're answering question in Quora or Reddit, it's going to skew your personality to, like, oh, you're always helpful, or you're answering questions and stuff like that. But it's interesting, okay? So I don't know how many of you are going to do this, but I find it very, very interesting. It also kind of tells you, what is the current state of AI, artificial intelligence. Because if an AI product can do that with high accuracy, what else can it do? So that's kind of a good question for you to kind of think about, because you are going to move into a computer science related, field. And I think artificial intelligence can change a lot of things that we don't even know yet. Is that making any sense or not? Yep. Okay. So that's MBTI stuff. And there's course information, semester base share folder. And here is a quick introduction, how to take a class from me. If you have a question in class, if I were to summarize, okay, if you have a question, ask the question, okay? Don't just, kind of think about the question in class, but go ahead and ask the question. I like questions. Is that okay? All right. Do your other professors, just kind of openly and explicitly tell you that questions are not only allowed, but they're encouraged? Because that depends on the personality type. Some people may not actually like questions, but I really like questions. Okay? Although sometimes I might answer your question with another question, so that you actually can answer that question and answering your own question as a result. Okay? Okay, so we can start now with the actual stuff for this class. This is going to be a very quick review. And by the way, I just follow the content of my class, in sequence like this. So if I'm talking about Boolean operators today, and you need to read ahead of me, so what are you going to read? Basic set theory. Okay? So that's how this class is going to roll, is if I'm on a particular module, read ahead of me by about a module, and you'll be fine. Okay? All right. But we didn't have time to talk about the Boolean operators. Well, this is stuff that you're supposed to know already, so I don't think you guys will have a problem with this. Why is it not opening? Did I forget to fix? Yep, I forgot. It's still going to the wrong website. It's okay, I can fix that. But I will have to fix it. There we go. So we have the conjunction operator, which you otherwise know as AND, A-N-D, or in C and C++ notation, what is it? Double ampersand, not a single ampersand. A single ampersand is bitwise AND, double ampersand is logical AND, which is what conjunction is. So this is just a weird way of looking at conjunction. If x is 0, false, y is 0, false, then x and y is false. If x is true, y is false, then x and y is also false, and so on. I don't think you need to have a table to remember or to be reminded of conjunction, okay? So the only time you get a true out of a conjunction is when both sides of the operator are true. That's the only time you get a true out of a conjunction. For all of the other three cases, you get false. The next one is disjunction. Oh, okay, the notation-wise, I kind of need to go through this. So notation-wise, this is how you look at it from C and C++ and many other programming languages. In mathematical symbol, it is like a TP, kind of like an inverted V symbol, okay, which I would use in this class occasionally, okay. So even if you don't plan to use this symbol to represent AND, you need to understand that it is the same thing as ampersand, ampersand. Sometimes, especially in electrical engineering, they would either use x dot y or x times y or just xy to represent conjunction. Okay, these two are kind of more specific to electrical engineering and also computer engineering. So if those are the fields that you're getting into, you will see a lot more of these in textbooks and whatnot. Okay, so these are all alternative representations of conjunction. Disjunction is what we know as OR, okay? So the only time you get a false out of an OR is when both sides of an OR are false. False or false is the only time you get a false. For all three other cases, if at least one side is a true, the result of a disjunction is going to be true, okay? So these are the alternative symbols. X bar bar y is what we use in C and C++ and many other programming languages. In mathematical symbol, it looks like a V to represent OR. Or if I use x times y to represent conjunction, then x plus y represents disjunction. Okay, so electrical engineers tend to use x plus y to mean x or y. Okay, why do you think electrical engineers use this symbol instead of the V symbol? Huh? Say it one more time. V is for velocity. That might be the case, okay? But there's also no such key on the keyboard for that particular symbol, okay? All right. So we're almost halfway through, okay? Negation. Negation is what we know as not in English. In C and C++, that's the exclamation point. In mathematical symbol, it is a kind of like a bar with a cliff kind of symbol. And in electrical engineering, there are two ways to represent it. If the software, typesetting software has the ability of overbar, in electrical engineering, that can represent negation. If without that, you can also use a slash to represent negation in electrical engineering. So if you read a lot of integrated circuit specification or data sheet, you will find a lot of literature using a slash to mean negation. So that's typically used in electrical or computer engineering. Not is pretty easy. Not true is false. Not false is true. So are there any questions about the three operators that you already know from C and C++? Yep, go ahead. Yeah, that kind of slanted arrow here, it means, not false is true, not true is false. So it basically means the negation or the result of the operator is this part here. So it doesn't, the slanted arrow itself has no meaning. So any questions about these three operators, logical operators? There are other operators. This one I just throw in for, quote unquote, for fun. If you have taken cisp440 from me, then you already know why the NAND gate is kind of cool. So does anyone want to mention that? Because I recognize a few faces from cisp310 from like the last semester. So what is significant about the NAND gate, which is a negated AND gate? Exactly. Well, that's one reason, which is a major reason. The second reason is it is one of the simplest logic gates to implement using transistors. Yep. He said it is significant because using the NAND operator, you can replicate all of the other operators. You can express AND using NAND. You can express OR using NAND. You can express negation using NAND. It is the one truly universal operator, which is kind of cool. So it is written here. Not X is the same thing as X NAND X. Does that make sense? Because X and X is just X, negating that becomes not X. Oh, that's what I just said. Not X. Whoops, right here. Not X. Okay? So that one seems pretty easy. What about X and Y? Okay, if I want to express X and Y, but only using the NAND operator, what is that going to look like? It's going to be X NAND Y, NAND X NAND Y. Because X NAND Y is the negation of X and Y, with that thing NANDing the expression itself, you're negating it. It becomes just X and Y. Okay? What about X or Y? I bet you cannot do that because and not doesn't seem to connect to or, but it does, using De Morgan's law. Okay, so X or Y can be expressed as X NAND X, NAND Y, NAND Y. In other words, these operators are not really needed. All we really need is just NAND. If I were to invent a new programming language, it will only have one logical operator, NAND. And then the first thing people would do is to write a macro to redefine all of these other mundane operators. So that's kind of the significance of NAND. It's just for fun, okay? We're not going to see NAND much more in this class. Implication is important. So implication, X implies Y, is by definition the same thing as not X or Y. That's how it is defined. Okay, so every time you see X implies Y, it is really exactly the same thing saying not X or Y. Okay, and of course it has its own truth table. Okay, if X is false, Y is false, X implies Y is true. If X is true, Y is false, true implies false is false. If X is false, Y is true, false implies true is true. If X is true, Y is true, true implies true is true. Do you think this one may need a little bit more explanation? So I have an example here. I'm just going to use this one. All right. So we'll say X is this particular statement. A blue cat is sick. Okay, it's just a condition. It can be true or false, right? Implies, that's the operator. Tomorrow is doomsday. That is also just a statement. It can be true, it can be false. In other words, a blue cat is sick is X, okay? Tomorrow is doomsday is Y. X implies Y as an implication can be true or false. Is that part okay? Okay. So let's just say that, you pay me $20, for a statement. And this is the statement that I gave you. And you look at the statement and go like, I think I just wasted $20. Okay? And you said, I want a refund. And I'm going to say, well, you can get a refund if the statement proves to be false. So now you really have to understand the meaning of implication because you want your $20 back. Right? So now let's look at the 4 scenarios. So let's just say that today you saw a blue cat and it's sick. And tomorrow turns out to be doomsday. Okay? So can you get a refund tomorrow? Not that it really matters because it's doomsday, but can you get a refund? No, because the statement that I gave you was true. Okay? That's the easy one, right? The next one is, it is not the case a blue cat is sick. Okay? It can be false in 2 ways. A blue cat is sick can be false in several ways. It doesn't really matter. All we need to know is a blue cat is sick is false. Maybe there are no blue cats. Okay? Maybe all the blue cats that you can find are healthy. They're not sick. I don't really care. But a blue cat is sick is turned out to be false. Okay? But tomorrow turned out to be doomsday anyway. Can you get your refund? You cannot get your refund because I never said anything about what happens when no blue cat is sick. So you cannot hold me accountable for that. That's the trick about implication, okay? So for the same reason, you cannot get your refund either if today there's no blue cat that is sick and then tomorrow turns out to be fine, okay? Oh, I got these 2 flipped here, but it doesn't matter because my statement didn't say anything about what happens when there are no sick blue cats. Okay? So it doesn't matter. If X is false, then the implication is automatically true, regardless of Y. In X implies Y. Is that okay? So the only time you can get your refund is the last one. You picked up a blue cat that is sick today, okay? And tomorrow is not doomsday. That is the only time my statement is false. And you can get your $20 back to pay for the treatment of the blue cat. Is that okay? All right? But the best way to look at it is really just look at the definition. X implies Y is the same thing as not X or Y. That's it. Mechanically, that is how it is defined. Is that okay? So if implication is, why is it important in this class? It's not an operator in C or C++. Well, because in this class, we need to prove theorems. And implication is the link between the steps in a proof. And that's why it is important in this class. So the last one of this slide is equivalence. And equivalence is pretty easy because if you say X is equivalent to Y, by definition, it simply means X implies Y and Y implies X. That's it. So are we good so far with the operators or the definition of the operators? We got 3 that we are really familiar with. and or not. And then we got two that are kind of like, oh, okay, I can see how they're defined. One is implication, the other one is equivalence. So do we have any questions about those 5 operators? No questions? All right. So now we can start to talk about set theory. We got about another 10 minutes. And some people may have some exposure to set theory in high school, and some people may not have any exposure, which is okay. I'm just going to assume, no one has exposure to set theory, before this class. So we start with, what is a set and what does it contain, okay? So if you want to look at basically a set is like a bag, okay? It's like it's a container, and it can contain items. The items contained within the container are called elements, okay? And there you go, okay? That's basically the idea of a set and what it contains, what we call elements. But there are a few things that we also have to remember. When we list the items or when we list the elements inside a set like this using curly braces, the order is not important. Okay, so if we look at this example here, let me highlight it. So when we look at this example, all it means is the set T contains the following elements. It contains the element 12, a number, a value, 5, 2.2, 7, -1, and 10. The order is insignificant, okay? I could have done exactly the same thing and expressed the containment of elements within the set if I sort it, okay? If I say T has the following elements, -1, 2.2, 7, 10, and, oh, I missed 5, 5, 10, and then 12. The order does not matter. Okay, as long as it is in the set, it means exactly the same thing. In other words, it is not an array. Okay, a set is not an array because in an array, order matters. Okay, and that's why we have arrays that are sorted and arrays that are not sorted because they are not the same. But in a set, it doesn't really matter how we list the elements inside a set. Is that okay? You cannot have duplicate elements in a set. That's the other rule. Okay? So in this particular set, I cannot list -1 twice. It can only be listed once. Is that okay? So understanding that part, now we can evaluate, or now we can define this operator. The operator is called element of. Okay, so let's focus on this particular statement. It is a statement, it is a condition, because it's either true or false. Okay? In other words, you can kind of put a little question mark on top of the element of operator, because it's really a question. It's asking, is it true or false that 2.2 is an element of T? Now, in this case, yes, okay? As it turns out, it is true that 2.2 is an element of T. So now we say 2.2 is an element of T is true. Okay. Then we look at the next one, which is 23 is an element of T. That is a statement or condition that is false, because in this particular case, the way I define T, 23 is not one of its elements. So 23 is an element of T is false. Is that okay? So the most common misunderstanding is 2.2 is an element of T is actually putting the element into T. That is not what is happening. Okay? 2.2 is an element of T is asking a question. Is it true or false that 2.2 is in the set T? So you have to kind of make that distinction and make sure that you understand it is a question, it is not an assertion. Is that okay? All right. So the next one, 2.1, asks you about, so how would you implement the concept of a set in C and C++? What do you think?
Well, you could use an array, but you have to move through the array and just, if they're all integers, you just add them up, and then you check the the other array that's you're comparing it to, and you just make sure that the sum of
You cannot. The sum can be confusing, because so let's say we use that approach. Okay, we compare the sum, but you have to remember, 2 plus 3 has the same sum as 1 plus 4. So you cannot distinguish those two anymore. So let's just say that I have elements from 0 to 31. Okay, those are the only potential elements I need to deal with. Okay, 0 to 31. Okay, what is one particular way to implement a set, to represent a set in C and C++? One bit for each element. Very good. I like that idea. It's called a bitmap. Okay, so bit 0 represents whether 0 is in the set or not. If 0 is in the set, bit 0 is a 1. If 0 is not in the set, bit 0 is a 0. Okay, what about 15? Well, same thing. If 15 is in the set, then bit 15 is a 1. If 15 is not in the set, then bit 15 is a 0. So this is really kind of compact, because all you need is an integer in most compilers to represent a set of 32 elements, because we start from 0. 0 to 31 has 32 possibilities. Is that okay? So it's pretty easy, and it's really fast too, because all you need to do is to check whether a particular bit with a 32-bit integer is a 1 or a 0. Okay, so we'll get to that kind of representation and implementation later in this class, especially when we get to combinations and permutations. Then we're going to write some programs, using the concept of a set. Section 3 basically talks about, how do we know whether two sets are the same or not? Okay, do they have the same elements? So the idea is, if every element in S can be found in T and every element in T can be found in S, then the two sets are considered to be the same, to be equivalent. Okay? A set can be an element of another set. Hold on a second here. This is a little bit complicated. We know that a set can contain elements, but a particular set can be an element of another set. In other words, they can nest. Okay? Well, that concept seemed to be pretty abstract and difficult to understand, but trust me, you deal with that concept all the time, every single day. Think of a set as a folder, and elements that are not sets as files. You got the idea? You can have folders within folders. Exactly. Wait, you can have empty folders, can't you? Right? So can we have an empty set, like a set that has no elements, it contains nothing? Absolutely. So that analogy actually works fairly well. Can you have two files within the same folder that has exactly the same name, like duplicate items? No. Same thing with a set. Within the set, you cannot have two elements that are exactly the same. They have to be unique within the set. Oh, okay, so that seems to work out. What about ordering? Like, does it matter, how your files are displayed in the file manager? Nope, because containment doesn't really care. Okay, so if you have two folders, okay, and you ask, well, if I remove this folder, can the other folder be a proper backup of this folder? You're asking, are they the same? Okay, and it's the same thing. If every single file in this folder can be found in the other folder, and every item in the other folder can be found in this folder, then it's okay. Of course, you have to apply that recursively, because a set can contain elements that are by itself a set. Okay? And then we have this idea, a set with an infinite number of elements. This is, well, we are running out of time. This is when things get a little bit complicated, because how do we express a set of even numbers, even integers? Well, it's infinite, right? How do we know it's infinite? Someone can claim, I think this is the last even number. What are you going to say? Exactly. What is 2 plus that then? So that means it's a set that has an infinite number of elements. So that makes it kind of difficult to express that, right? So in the next class on Monday, we'll resume at this point, and then we'll start to think about, okay, so how do we characterize a set that has an infinite number of elements? Okay, so read ahead of me, and I'll see you guys on Monday.